There's a base that's called the natural base, and it actually has a letter designation like pi. Pi is 3.1415, blah, blah, blah. There's another number, maybe you're familiar with, maybe not, but it's called the natural base, and it's base E. Like I said, base E is a number like pi, except it has a different value. Turns out E is equal to 2.718281828. And it looks like, well, it's repeating, but the next number is 4, 5, 9. So it's like pi. It doesn't have it doesn't terminate. It doesn't have a pattern. It just keeps going infinitely. But it occurs naturally, and we'll talk about some places it does occur. We'll get one later today. A place where it occurs naturally, but it's called the natural base. For various reasons, it's called the natural base. E is 2.71828, what you see there. So it's about 2.72. You know, we round off pi to 3.14. Well, E is about 2.72. Now, it's just like any other number, though. And the good news is the calculators come equipped, most scientific calculators anyway, come equipped with an E button. So it's very easy to evaluate E to a power. Just punch it in. E squared then would be, just find that E button on your calculator, and 7.38905, blah, 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 okay? So yeah, it's like any other number. You can raise it to powers and do all sorts of things to it. Now, e to the negative 1.8, is that going to be a negative number? No, it's just 1 over e to the positive 1/8, but you don't even have to know that, just punch it in. It's going to be a small number, yeah, 0.1652988, something to that effect. Okay? All right. So if we graph these functions, our exponential functions, and we have base e, what's that going to look like? E to the x, that's our hockey stick, right? Same thing, and it's the increasing, because e is bigger than 1, it's an increasing hockey stick shape, but and we'll see if we do our little table here. See, I didn't do e to the negative 2 yet. E to the negative 2 gives me 0.135, e to the negative 1 gives me 0.37. Of course, e to the 0. E to the negative 0 power is 1, so e to the 0 is still 1. E to the 1, well, e is 2.718, so it's about 2.72. And then e squared, well, we just did that one, it's about 7.4. Yeah, so those values show, again, we're just talking about that hockey stick shape growing exponentially increasing. At 1 we're at 2.72, and then at 2 we're at about 7.4. About there. So yeah, same basic shape, don't we? Got the horizontal asymptote out here at the x-axis, y equals 0, in other words. All right, what about this one? F of x equals e to the minus x minus 2. Well, that's got the minus power, x, and so that flips it around. It becomes a decreasing. The minus 2, well, that's on the outside there, and so that's going to shift it down 2, which also makes then the horizontal asymptote down 2. So the horizontal asymptote is going to be at negative 2 now. Y equals negative 2. So get those values then plugged in. All right, so that would be, all right, what we got? E to, so that would be e squared minus 2. What, 5.3. 9. Plug in negative 1, you have e to the positive 1 minus 2, or e minus 2. So that's 0.72, about. 0, e to the 0 minus 1, minus 2, be 1 minus 2, so that's be down at negative 1 there. And then e to the minus 1 minus 2. About a negative 1.63, and then at e to the negative 2 minus 2, about a negative 1.865. Yeah, so that all that shows you got your horizontal asymptote down there at negative 2, but it's the decreasing, right? Negative 2, we're at 5.3. Negative 1, only 0.72, 0, I'm at negative 1. And then 1 and 2, negative 1.63, negative 1.65. Yeah, so we've got this shape, and yeah, the horizontal asymptote's out here at negative 2. Okay. So that's the natural rate. So it'll come up quite a bit in some things we'll talk about.